This lecture is going to talk about a special random variable called the normal distribution. So chapter 7 has been dealing with this general topic of random variables. So random variables assign numbers to outcomes, and different random experiments will give rise to different random variables. And we've already talked about a couple of these. We've talked about a general discrete random variable, and we found out how to find its mean and variance. Then we talked about a specific random variable, which is the binomial random variable. And so binomials arise whenever you observe a series of yes-no events. So I observe whether you click on a banner ad or not, and I do this for a whole bunch of people, and then I count the number of yeses. And so whenever you do that type of random experiment, you get a binomial. Another really important special random variable is this normal random variable. So normal random variables will arise very often, and we're going to be using it throughout the rest of this course and the next one. So what is a normal random variable? Well, a normal random variable is going to be one that has a probability histogram that has the familiar bell-shaped curve. Now, if you want, excuse me, an equation for that, I actually give you the equation of that curve in the footnote. You're not really responsible for that, but often students are interested in the equation of it. So that's what a normal random variable is. It's also called a Gaussian distribution after the German mathematician Carl Friedrich Gauss. When it comes to using the normal curve in this course and other courses here at IMC, we really care about finding probabilities under the normal curve. And there are really three types of probabilities that we care about. So either we're going to care about finding the area in the left tail of the normal curve. So to give you a slightly more concrete example, if we want to find the area in this tail, that would be an example of finding a left tail. Secondly, we might want to find the area in the right tail. So if we go down a little bit further, here's an example of the right tail. The third type of probability that we may want to find is what I call a slice in the middle. So this is an example of a slice in the middle. So the lecture on the normal curve today amounts to showing us how do you find these three types of probabilities. Now, the answer is we're going to use either Excel or a normal probability table. So, remember, with probability histograms, probabilities are always proportional to areas. So finding these probabilities, it really just corresponds with evaluating this area. Now, those of you who've had calculus might say, well, areas, that's just integration. So all I'd have to do is integrate this curve. And I've got the equation up here. Just go find the integral, and that would get me to the probabilities. But there's a problem with that, in that this equation turns out to be very difficult to integrate. In fact, it's impossible to have to find the integral to evaluate slices as we'd like to do. All right, so that kind of rules out calculus. So what are we going to do instead? Well, we have to do what I said earlier. We're going to either use Excel or use a normal table. So a little bit of background on this. What's really happening behind the scenes with either of these is that you're doing numerical integration. So if you remember the trapezoidal rule from your calculus class, that's what's happening behind the scenes, but you don't really need to worry about that. Okay, so let's talk about these two options. Excel offers some functions for evaluating areas under the normal curve. There's two functions, norm dist and norm sdist, and we can use either one. Let's talk about the difference between these. So norm dist does normal distributions. Norm sdist, the S in here, stands for a standard normal distribution. So let's talk a little bit about what a standard normal distribution is. So standard normal distribution is a pretty important concept for us. It's a standard normal distribution is just a normal distribution that has a mean of 0 and a variance of 1. So by convention, whenever we have a distribution that has a mean of 0 and a variance of 1 and it's normal, we're going to use the letter Z for the random variable. So whenever you see a big Z, chances are it means a standard normal random variable. Now, why have this this standard normal curve? Well, in the olden days, we would have one table in a book. All right, one table for evaluating normal probabilities in a book, and we couldn't have a table for every possible normal curve with every possible mean and every possible standard deviation. So it turns out that you can take any normal curve and convert it into a standard normal curve. So what this means is that if you start out with any normal curve, you can find areas under that by first converting it to a standard normal curve. Then you go off and you either use a standard normal table or the norm sdist function in Excel, and you can find these three types of areas. So let's talk a little bit about how you make that conversion. So I call this the important theorem. If x is any old normal curve with some mean mu and some variance sigma squared, then you can convert it into a z just by taking x minus the mean divided by the standard deviation. Okay. Now, you did hear me say in the olden days this is what you do. I've thought long and hard about whether to still include this, given that we have Excel's norm dist function. So norm dist doesn't require standard normal. But I think it's very important for you still to know this, because this language is going to come up in the next course when you talk about factor analysis. You're going to have standardized regression coefficients next quarter, so it's really important for you to know, this standardized normal notation. Okay, so one thing about this, so Z is going to be measured in standard units. So the unit of a z-score is its standard deviation. So every unit then is 1. All right. Now let's go off and do some examples to illustrate these three types of probabilities that we want to find. So here's a little problem. Let's say we have some standardized test, and that standardized test has a mean of 50 on it. So the average student gets a 50 on it. And let's say that things have been set up on this standardized test so that the standard deviation is 10. So let's define X as a test score for some randomly selected student. Problem 1. What is the probability that the test score of some randomly selected student is less than the value 38? Okay, well, let's go draw it. I always recommend drawing these things because it will help you keep things straight. It really helps to visualize it. So I always draw my normal curve and I write the mean and the standard deviation above it. So this thing has a mean of 50 and a standard deviation of 10. And what we're asked to find is the chance that some score is less than 38. So here is 38, right here. And so I've shaded this area. So what I need to do is evaluate that area. All right, let's go over to the left now. And the notation I think students have a problem with, but if you can master this notation, I think it will really help you. It's very much worth going through it. So we're asked to find the probability that a randomly selected student, so that's an X, is less than 38, has a test score less than 38. Well, I'm going to first convert this into standardized units. So remember, I can take any normal curve. Here I've got one with a mean of 50 and a standard deviation of 10, and I can convert that into a standard normal curve. Here's the way I do that. I use this formula that you had before. So take x minus its mean, divide by its standard deviation. So the probability that x is less than 38 is exactly the same thing as the probability that I have a standard normal random variable z being less than 38 minus 50 divided by 10. Now if you do this math, you're going to find that it equals minus 1.2. Now, I said to you earlier that the units of the standard normal curve, standard units, are the standard deviation. So let's interpret this number in view of that fact. So what this means is you are 1.2 standard deviations to the left of the mean. Okay, the negative sign means to the left of the mean. And let's just think about this. So the mean is 50. If I go one standard deviation to the left, so the standard deviation is 10, that takes me out to 40. Okay, I'm not quite at 38. So I need another 2/10 of a standard deviation to get to 38. Okay, so I'm 1.2 standard deviations, and again I'm to the left of the mean. All right. Now at this point, I'm going to go either to Excel or to a normal table. So if I just go to Excel and type in normdist minus 1.2, let's go do that right now. Let's go to a new sheet. Let's make the font real big. And if I type equals norm s dist minus 1.2, what you're going to see is that the answer is 0.1150. So if we go back, the area in that tail is 0.1150, which actually gets rounded up to 0.1151. Okay, so that's one possibility.